Welcome to the Engineering for the New Reality podcast series, where we're talking to our LTTS engineers about the challenges and opportunities pertinent to today's business environment. You know, as more people begin to operate virtually in this new normal, it puts that much extra load on our data centers. A simple power failure in a data center can shut down public services, cause pandemonium in various businesses, and result in millions of dollars in losses. Now, more than ever before, we need our data centers to be operational 24/7. To talk a little bit more about this big unplanned downtime problem that data centers have and the solution that LTTS has come up with, we have with us Abhijit Naik, who is our Director for Predictive Maintenance Solutions based in Stockholm. Hi Abhijit, welcome to the podcast. How's it going in Stockholm?
Hi Akshay, thanks for inviting me to the podcast. Everything is going well. It's a nice sunny day here in Stockholm, so it's beautiful today.
Great. So Abhijit, now more than ever before, data centers form the backbone of our virtual economy. What are some of the major uptime and outage issues that data centers face today, and how is it impacting their ability to perform optimally?
Sure, Akshay. See, I'll just set some context up over here. So, as you mentioned, data centers are becoming one of the most critical components for our digital economy. They are growing at a fairly fast clip. We are getting approximately 14% growth rate annually all over the world globally. Now, as this global also in the current situation, right, as the global demand for remote working is growing due to COVID-19, and most of the services now for supporting remote working is either cloud based or is hosted in a data center environment. This is also growing quite a lot, right? So for this, the data center uptime is becoming extremely critical, actually now for society to function, because we are using more and more digital services, right? Now, one of the major issues which is coming up because of this, large scale out which is happening, and the scale out is happening because the data centers itself are increasing non-linearly in size, and the internal complexity of what all is being provided by the data center. Now, the issue that is arising is that the probability of uncontrolled failure or unplanned equipment failure outage is increasing quite a lot also, just because of the sheer complexity and the diversity of and the load that data centers are being put under, right? And now, if you really look at this equipment and you look at the root cause analysis of what is causing these failures, majority of it falls into equipment related failures. This is power or HVAC or the cooling subsystems, cracks. This is one, and the other part is the IT infrastructure, that is the network connectivity infrastructure. These are the ones which are causing majority of the failure, right? And in this, the physical equipment, the UPS, generator, HVAC, and cracks. If you add this up, this is more than 50% of the potential failure that uncontrolled outages that happen, right? Now, what is the impact of this? See, the impact of this on the data center operator is, or the co-location operator is, that they have service level agreements with their customers. And there's an uptime requirement. There's a very stringent uptime requirement which is typically in place. This impacts that. And these SLAs also have commercial penalties associated with, an uncontrolled failure or a service level disruption. So, that's a major impact that comes into play. And, if you also have something big happening, there is a huge reputation impact, which is non-monetizable, but, it spreads in the industry that, so-and-so had something like this. And if it's a major service impact, like, if a stock market software is being hosted on an environment and the hardware goes down, the stock market trading is affected. Or if it is an airline reservation system and the data center goes down, or the service goes down, it has huge impact. It's press and things like that. So these are the typical impacts that the data centers are facing if they have uncontrolled failure.
You know, it's interesting you mentioned that over 50% of unplanned outages happen due to power and environmental equipment, such as HVAC, cracks. So, what are some of the ways in which data centers can reduce these unplanned outages, and would it require multiple levels of measurement and reporting?
Yes, it does. So, see, typically, if you have, to build redundancy into the system, you typically have three approaches that the data centers are taking. First one is what is called as distributed resiliency, right? Effectively, what you're doing over here is you have multiple physical data centers in different locations, and you create a software layer which is unifying, connecting all these data centers, and then you deploy the service on this software layer. This is used by cloud environments or hyperscalers over. So having a single logical entity from software perspective, but physically distributing it across different locations. So if one of the data centers has an outage, the other physical locations can seamlessly take over. Um, but this is technology. This is work in progress, and this is also not applicable for a lot of use cases where the your software is latency dependent or timeliness dependent, or there might be security issues and things like that, right? So this is one mechanism, right? It's showing good results, but it's again work in progress right now. The second mechanism which is there for increasing redundancy is to create what we call as a 2N architecture, for both power and then cooling at site, HVAC, etc. at site, right? And this 2N architecture, is expensive because you have two pieces of equipment for just for redundancy. And even if you use the 2N architecture, the interesting fact is that 22% of the uncontrolled outages, if you see last year, approximately 22% have occurred in a 2N architecture environment, right? And if you look at over a 3-year spread, about 35% of the uncontrolled failures, outages have happened in a 2N architecture environment, which is still a fair amount of failures happening, right? If you don't have a 2N architecture, you have something called as what we call as N+1, which is most of the data centers out there today. These numbers are much higher. Like for last 1 year, it is about 31%. And if you look at a 3-year window, uncontrolled outages about 55% of the uncontrolled outages, right? So, we even if you use 2N, we have to look at other techniques over here. Now, the third important issue which is coming up is that there is a lot of legacy assets out there today, right? These legacy assets um, mean that you have exceeded the expected life cycle of using the equipment, right? They were designed for 5 years of deployment or 10 years of deployment. We are beyond that, right? 35% of the assets today are in this legacy asset state. So here the probability of failure is much higher. Uncontrolled failure is much higher, right? So how do you handle this? You need to detect that this failure can occur. You have to sensorize the equipment, and then you have to focus on criteria that will catch, some of this uncontrolled failure. Right? You have to use analytics. You have to use real-time monitoring. You have to use something like digital twinning to diagnose and then to predict the probability of this thing occurring. Right? And then typically this stuff is not very expensive. So now we are hitting the price point that you can do all these things, get good ROI, and be able to predict and catch these issues. Right. So this is where we are today.
So, building on what you just said about sensorization, detection, analytics, could you talk to us about LTTS's predictive maintenance solution for data centers? How does this solution help in all the things that you just mentioned, and then in creating intelligent digital twins for machine diagnostics and prognostics?
Okay. So see, LTTS as a company, we have been we are an engineering company, right? Engineering R&D services company. We actually work with most of the manufacturers and the equipment, people who make equipment, HVAC OEMs, electrical equipment OEMs, etc. So we design it, we test it, we have our own labs where we assist in the development, etc. Right now, because of our background over here, what we have done is we have created, um, a solution called LTTS Everton. This is an IoT-based scalable solution which can suck all the information which is coming from this equipment, and then we have used this to create a predictive maintenance solution, right? So this will detect it. So we will sensorize, we will detect, we will analyze, and then we will also give you diagnostics and then prognostics about the equipment, right? Because we have created these high fidelity models that can tell you what is happening with them. With this, we can actually predict the remaining useful life, the current operating zone you're in, green, yellow, red, etc. Asset health state, and then the degradation state, current degradation state of the equipment, right? And with this, you can do early failure detection on the edge, right? We are doing edge computing with machine learning models. We are creating hybrid models where we are doing both physics-based analysis, and with that, we are predicting the operating and then the failure curve of the equipment. And then we are also integrating that with the machine learning model so that as real-time data is coming in, we can keep updating the total model based on the evolution of the product and the system over there, right? And the third thing that we are doing is we have also set up this 24/7 monitoring infrastructure so that we can tell you what is happening with the equipment, give you the notifications, give you the alarms, etc. And then based on this, you can take actionable, you can take actions. You have insights of what's happening with the equipment. You can take maintenance action, and then you can also do prognostics. Based on the prognostics, you can decide what you want to do with the equipment.
Abhijit, in today's environment with so much of focus on remote working and virtual business operations and safety, why is this solution so relevant?
Oh, see, today, if a data center goes down, it really impacts society as such, right? See, from the work perspective, companies, because of the COVID-19 situation, have set up their business continuity plans where most of the operations are being done remotely from home. Right, 50 to 70% of the people are working from home, and we expect this type of a ratio to be in place for the immediate future, at least in next 6 to 8 months, 9 months. Let's see, right? So all this infrastructure, all this for you to be able to work from home, the data centers have to work because all the services are deployed over there. The second thing is, even if you're not working, if family is there, nobody can step out of the house. So a lot of the entertainment, home entertainment, like Netflix or gaming or on-demand TV, internet service, etc. All of this stuff is hosted on data centers, right? So even from home entertainment perspective, for you to stay at home or work from home, the data center has to be up and running. So if this thing goes down, you know, you can't work, and nor can you get access to your content, basically. So it's a big issue. And if you have to maintain social distancing, and data centers have to be up and running.
So, Abhijit, let's discuss on a very important topic, commercial models and ROI. So, what kind of investments would a data center be looking at to deploy the LTTS Avatel solution? And how can we directly link LTTS's predictive maintenance to data center business returns?
Mm. See, we actually are fairly flexible in the sense that we support both capex and opex oriented business models, right? In the sense that if you are a greenfield rollout, if you're building a new data center, then we can actually work with you and give you a capex based approach, so that as a part of your equipment installation and commissioning, you also install the predictive maintenance solution, right? Um, the second scenario is a brownfield situation where you already have existing infrastructure, and you either want to increase the predictive and the prognostic capability for that infrastructure. So there we can give an OpEx oriented model where that you actually pay for it across a period of time. So we support both these business models, right? Then we can also provide managed services for you. The other benefit that people are seeing, from an ROI perspective, when they deploy a PDM system like ours, right, is typically you will see about 20% reduction in your maintenance cost, right? Because you don't have to do calendar-based maintenance. You can do it on the condition and the prognostic-based maintenance. And it is more relevant because it is based on the actual state of the equipment. The second thing is that you get about 15 to 20% again reduction in uncontrolled outages because you are focusing on the equipment that can fail in an uncontrolled manner, right? And then you can take actions to ensure that either you have a backup in place or you take it through a maintenance cycle, right? And the third huge improvement that we are seeing is about 80% improvement in terms of maintenance accuracy, right? Where rather than being reactive when an uncontrolled failure has happened, and then you are struggling to make it up, make it run again and provide the service and then maintain it. Your Now you can actually detect what is happening with the equipment, and in a very controlled manner, have high accuracy in terms of the state of the equipment, and then take remedial action to fix it. So these are the benefits and the ROI that data centers are seeing.
Thanks, Abhijit. I'm sure this gives data center operators a lot to ponder about, but more importantly, take necessary action to eliminate unplanned outages. To all our listeners, thanks for tuning in. We have a bunch of other amazing episodes in our Engineering for the New Reality podcast series. Do visit our website at www.ltts.com to get access to them. Thank you, stay safe, and have a nice day.